Okay. Let's take a look at another one. First of all, we have the isolated trig term cotangent. It's cotangent of 3/2 x. Again, we're not going to address that fraction until we get rid of the cotangent. And I'm not going to deal with cotangent. I'm going to deal with tangent. Now, if you go back and you look at the couple of times that we've had these reciprocal functions, okay, we can swap that out for its reciprocal equivalent and then do the switcheroo, okay? But we can combine these steps. What eventually happened, right? We took this out of the fraction and we put this under the fraction, right? So if you want, we can do that all at once. Meaning I can swap out the cotangent for a tangent, and I can take this and slide it into a denominator. Okay. So now we have 1 over radical 3. So this becomes the tangent of 3/2 x equals negative. You know where this is going, I hope, at this point. We have negative radical 3 over 3. Then we can arctan both sides. Where is tangent negative? I'm going to space this out a little bit because I think I see where this is heading. What pi values have tangent values of radical 3 over 3? I know those are pi over 6 angles, but I'm not writing pi over 6 as my solution. Okay, where is tangent negative? Tangent is negative in quadrants 2 and 4. The pi over 6 angle in quadrant 2 is 5 pi over 6. The pi over 6 angle in quadrant 4 is 11 pi over 6. And we do have one of these coefficients for x. So while we're here now that we've talked about this, what this means, okay, we can. I've got a different way that we could talk about it if you want. That might make a little bit more sense. But now that we've talked about this, while we're here, let's add a couple of coterminal angles. Not saying we're going to include them all, but let's add them anyway. So, like, what's coterminal with 5 pi over 6? Well, then it would be, here's 5 pi over 6. It would be 5 pi over 6 plus 12 pi over 6. That would be 17 pi over 6. And coterminal with 11 pi over 6 would be, starting here, 11 pi over 6 plus 12 pi over 6 is 23 pi over 6. Now I'm not done yet. I still have to actually isolate x and solve for that. So I'm going to do that by multiplying by this reciprocal. Right? That's how we get rid of fractions that are in front of variables. We're dividing by 3 over 2, but if we're dividing by 3 over 2, we're multiplying by 2 over 3. So over here, I'm multiplying by 2 over 3 as well. So I'll have x equals 10 pi over 18. Yes, I know that can be reduced. 22 pi over 18. All I'm doing is taking the 2/3 and multiplying it times each one of these. 34 pi over 18 and 46 pi over 18. Now, which of these do I get to include? Well, that's 5 pi over 9. That's definitely less than 2 pi. That's 11 pi over 9. That's still less than 2 pi. That's 17 pi over 9. We're getting close. How many ninths is 2 pi? I'll ask that question again. How many ninths is 2 pi? 2 pi is equal to blank over 9. 18. Right? We just doubled the denominator, right? So I got to stop short of 18 pi over 9, so I'm definitely sure that's not going to cut it. Okay. So So for problems like this, once again, for problems like this that have a coefficient for x, we are only interested between answers between 0 and 2 pi. Okay? So we'll write it like that. Here's what I was saying, and I'm going off the cuff here for a second. Okay? Stay with me. Actually, let me do this in another video as a second example of why.